Hey everyone, my name is Mike Safianoff, and today I'm going to be talking about timing and spacing. So those are always mentioned in the same sentence when you're talking about the 12 principles of animation, because it's really hard just to sort of separate timing and spacing into their own principle by themselves. So timing, I think, is a little easier to sort of explain. Spacing, I think I'll actually have to show you some examples. But timing generally means two things. The first thing it means is kind of just the amount of time that it takes to do an action. Like if a ball is falling out of the sky and it hits the ground and it takes 2 seconds to fall from its apex until it hits the ground, it takes 2 seconds. That's the amount of time it takes, and that's sort of timing. Timing is the time that actions take to start and complete, but they're also the energy of the character, and that's kind of why timing is always mentioned with spacing, because spacing actually sort of determines sort of the speed that actions actually take place. It may take 2 seconds for that ball to fall out of the sky, but for the first several frames, it's actually, if it's a bouncing ball, it may actually be hanging out at its apex, waiting for gravity to sort of take over and send it back down to Earth. And that's why timing and spacing are always sort of mentioned together, because spacing actually determines the speed of things. Timing actually sort of refers to the length of actions themselves. It's a little weird, I know, but that's what today's class is going to be all about. So here's an example of spacing with Wile E. Coyote here. If you just sort of took the foot as it's sort of traveling across screen in this sequential image, and you just sort of looked at each sort of placement that the foot is actually inhabiting, you can kind of see that there's a space in between each position. And that space, that spacing gap, is what actually sort of determines how fast something travels across screen. If this foot was only existing for one frame at a time and you played several frames sequentially, you would kind of see it traveling across screen, and the speed in which it's actually moving across screen is determined by spacing. But the rate in which that foot is traveling is actually what really sort of makes that run feel like a run and not just a really oddly posed walk or something like that. And if by kind of controlling the spacing gaps and controlling the acceleration of spacing gaps, we can really begin to create believable motion. There's no motion that really sort of exists that kind of can be created out of nothing unless it's being hit by something else or really being acted upon it by something else. As you'll see in Joe Bowers' class, physics actually play a huge amount in all animation. So specifically today, I want to talk about a bouncing ball, just a bouncing ball going from its apex to the ground and then back up again in a looped cycle. And we're really only going to be talking about the ball going up and down, not covering any distance or anything like that. Really, so this way we can have you focus on creating kind of this accelerating and decelerating spacing that's really going to be so important to everything. Objects tend to need to accelerate before they can really kind of hit their maximum speed, and objects usually are always accelerating or decelerating. Today we're going to focus so much attention on just the bouncing balls, translate why, because we really want to focus on the concept of ease in and ease out. We don't want to create uniform spacing or constant speed with our bouncing ball today, because that kind of feels unnatural. We want to really kind of get momentum and gravity involved in our ball, and really momentum and gravity involved in all of our spacing choices, because everything that exists on this planet has momentum and gravity being acted upon it. So this idea of ease in and ease out is kind of another way just to say accelerate or decelerate. Like, are you accelerating into your next pose or are you decelerating into your next pose? So for example, if you're traveling from here to here and you start to accelerate slowly and then kind of pick up speed and then wind up in your next pose like here, like if you were starting to lean forward on a walk and then kind of pick up speed into your natural walking speed, that you would be easing into that motion. If you were doing the opposite, if you were already walking at a constant speed and you were slowing down to a stop, you would be easing out of your constant speed and into your next position. And by harnessing kind of this natural sort of spacing, you're going to be able to create believable motion, but you're also going to be able to create energy, and you're really going to be able to create characters and feelings, because the way that a character moves around a room is going to tell you a lot about how they're actually feeling and who that character is. So good spacing, believable spacing, is one of the most important things to character animation, in my opinion, because it not only allows you to create believable motion and motion that actually feels physical and real and like it belongs on planet Earth, but it also tells you a lot about characters and actually kind of like who they are and how they're feeling and if they're a cat or not. Okay, so first I'm going to demonstrate doing a bouncing ball with a little bit more of kind of more like a 2D approach. I'm actually going to not use the computer to interpolate any frames whatsoever. So if I was going to actually drop it from here to here, I'm already getting sort of a computerized version of spacing. It's a very sort of constant speed. It's not accelerating or decelerating. It's not really acting like a ball, but it's at least kind of something to start with. And you just kind of need to manage your in-betweens on your own. Like, this is just sort of what the computer gives you right out of the box. But what I want to do is actually create my own spacing completely by hand. So what I'm going to do is I'm going to select all of my curves, and I'm going to go to step spacing. And what that does is it doesn't interpolate anything whatsoever. It only just sort of allows me to see my two keys. And what I'm actually going to do is just go ahead and kind of do this bouncing ball completely by hand, like the same way that I would if I was actually doing it with paper. So I'm just going to go ahead and change my preferences really quick. Just for the purposes of the demo, I'm going to go ahead and make my tangents always be stepped. So I think I'm going to go ahead and just sort of straight ahead this, and I'm going to do it on 2s. Oh, and I'm using auto key. Auto key I know is on when I see a little red box around the little key here, right here. And auto key just means that it's automatically going to set a key every single time that I move something. So here I have just my very first spacing gap. It's not very large, and I'm just sort of starting to show some acceleration. Here you can see that the ball is dropping a little bit faster. Here I want to kind of keep going with that. And I just kind of want to check my spacing sort of the same way that you would flip your pages back and forth on your ball if you were actually doing it by hand on paper. I'm just going to go ahead and kind of skip between keys and just sort of scrub, just to sort of make sure that my spacing is actually increasing the way that I want it to. It's important that it continues to accelerate, but it also accelerates kind of in accordance with the frames preceding it. You don't want there to be any large spacing gaps or anything like that that sort of seemingly come out of nowhere, and then see, for example, this gap and then this gap are almost the same size. So I really want to make sure that the next gap is much, much bigger so the ball continues to accelerate. And I think I'm just going to change my timing here. I'm going to make it a 12 frame drop instead of a 15 frame drop. So now you guys can kind of see just an initial sort of pass with the ball in kind of more traditional sort of timing and spacing. Just a very simple sort of example of how the ball is sort of accelerating as it's dropping, and you get absolutely no computer in-betweens in there, so this way you can just kind of have this as a rough starting point. So here we just have an example of just simple accelerating spacing with step tangents, the same way that you would kind of be working if you were actually going to draw a reframe or pose a reframe in stop motion or something like that. There's no computer in betweens, and I'm really just focusing on just kind of making my ball feel like it's accelerating into the drop. So let's take a look at this in the graph editor. So the graph editor is kind of a weird thing to sort of wrap your head around, but well, first let me just talk about this in step. So this is a weird looking curve because it's in step keys. There's no computer interpolation whatsoever. But you can kind of see what the curve would sort of look like if you just sort of drew a line from the keyframes, these little black dots here. So ignore what the green line is doing, just focus on the red line. And what this allows you to do is kind of see roughly how you're actually transitioning from a value around 11 to a value around -8 or so, kind of your last pose here. And really that's all that's actually happening in the graph editor. I'm going to go ahead and spline this so we can actually kind of see the curve as the computer likes to think about it with the actual value interpolation. So all the graph editor is doing is basically showing you how you're actually transitioning from a position of y at around of around 11 to -7. And in posing terms, that just sort of means your pose A at the apex and your pose B when the ball has actually dropped. So by seeing this value change represented in a line like this, you can kind of get a better idea of how your spacing is actually working, and you can kind of fine-tune things on a curve level and actually kind of adjust your spacing, so this way it's a little bit nicer without kind of having just to sort of eyeball it. This is especially important when you're working with a more complicated character and you have a lot of different body parts and you just kind of need just to sort of adjust your spacing and kind of clean things up. Like right here, I'm actually going to go ahead and I'm actually going to bring everything up just a little touch, so this way I get just a little bit more of sense of acceleration. This was accelerating just a little bit too fast for me, before the adjustment. And these little adjustments are actually really easy to make in the curve editor, and such kind of fine-tuning things may not actually kind of be noticeable by eye, but they're going to really add up. And especially when you're working with a more complicated character, these little adjustments can be really valuable because they don't create conflicts in other parts of the body. If there's a problem on your body spacing, it's going to affect all the spacing of your arms, your head, your legs, everything. And by kind of making sure that your curves are clean and your spacing is really accurate, it's not going to give you any sort of counter animation problems with the rest of the body.